Alright, so I wanted to do another video on EMI for residential kind of protection of the equipment, not so much health, but I think that there are a lot of parallels between the two, but it's going to be more localized, because the more I think about it, the more it's like, well, we're being bathed in high frequency radiation constantly now. It's what the digital era has brought us. So in some regards, the way to fight that is antioxidants, earthing, hydration, all the normal stuff. Maybe a little bit more, but from an equipment standpoint, I think there's a compounding effect when you have the atmosphere excited with high frequency radiation, and the voltage being supplied to the equipment being excited with high frequency. I think it's probably compounded over the length of the wire, power density wise. It would be my suspicion anyway. Anyway, this is the thinking I've kind of changed my mind on. So before I mentioned putting the ferrite beads before your electrical meter to avoid the added cost, because it would be feasible to just clip them on when it drops down the side of your house. The downside to that is if you have a smart meter like I do, and like I think most people do now, the smart meter does just that. It uses the electrical lines as a carrier for communicating information about your usage. So that's a high frequency signal in your line voltage that you would want to suppress coming into your house. So it makes sense to actually have it on the outlet of your meter, even at the additional cost, because that's actually a major source of radio frequency contamination of your electricity. And so that's kind of something I wanted to change my mind on. And additionally, I made a couple purchases because I was like, the best thing is to think about what's most important, what most expensive. So I have a very expensive heat pump, which is variable speed, both the compressor and the outdoor fan motor. So the way that works is that's literally just like a transmitter too, that chops up the line voltage and then uses it to spin the motor in chopped up bits that look like DC, but that chopping converting effect acts like a transmitter. So that's something that's going to be outputting dirty signals into the wire, or dirty kind of noise, radio frequency or whatever, back EMF, whatever you want to call it. But it's also equipment that is incredibly sensitive to dirty electricity. So you would never want to hook that up to a generator that wasn't like inverter driven, because the high probability of damage in the circuit board, which has about 13 capacitors on it, all of which are susceptible to damage and voltage spikes. So I'm gonna I purchased and I'm going to be installing a noise filter right in the electrical cabinet of the condenser. I got one rated for 30 amps. I think my actual condenser amp draw is like 12. But I'm, over engineered because I really just want to hit those high frequencies. I don't want to be energizing the coil unnecessarily. So I got an oversized one by about twofold. And then I got one for my furnace as well. For the same reason, the fan motor on that is a $700 fan motor. I know because I had to order one for someone today or the other day. But it's, it's something that you got to spray WD-40 on and make sure it's protected from voltage spikes. And that's pretty much all I can do if I want to save myself that money. So I think it was like $15 for each one of those. Now I have a surge protector on my meter. I'm going to be installing the Farabeats, but still I think the point of use ones make sense because you have the possibility now of these signals being introduced at all sorts of points throughout the house. You plug in a DC inverter, and all of a sudden, and you're not within 15 feet of an outlet, all of a sudden everything's a waste of time because your power is just as dirty as everyone else's. So getting the important stuff right at the point of use kind of protects that equipment. It's dedicated to that equipment, and anything introduced after your last filter isn't going to contaminate it, and anything coming in from the line isn't going to contaminate it. Anything that fails on it should be related to cycle duty and not, mismanagement. So that's the decision I made, basically, is protect the house from the meter as opposed to try to cheat. Well, not cheat, but put the burden of clean electricity on the provider. I'll carry that burden to protect myself from their meter, and to go with the additional layer of point of use or protection for my most expensive and also inverter driven motors in the house. And I'll tell you, if I had a washing machine that was like $2,000 or something like that, I would probably put it on that too. Just at the cost of repair replacement, I think the $35 is probably worth it. Yeah, so fortunately I just have a really expensive furnace and a really expensive condenser heat pump. Well, I also have a tankless water heater. Maybe I should get another one. No, maybe. Navian's all. It just a variable speed motor in it too. I'll think about it. Anyway, that's it. That's the tactic, is to go at the point of use for the things I'd like to really protect. Hardwire those in. Ferrite beads after the meter, because after taking into account the emissions from the meter, I want to protect my system from their system. And if I do it the opposite way, my house is an antenna and I'm muffling their transmission, which might draw their attention. So we're going to not do that anyway. So yeah, that's it.